Welcome everyone. In today's class, we are moving on to the second part of computer networks, that is regarding the topologies. In the previous class, we have seen an introduction to networks, the different types of networks like LAN, WAN, MAN, PAN and VPN, and we had also seen the differences between intranet, extranet and internet. And in today's class, we are moving on to the topologies part, an introduction to topology, the different types of topology and real life application areas of topologies. Coming on to an introduction to topology. Before getting into the types of topologies, we have to be aware of the term topology. What is actually topology? We can define it in many ways, like it can be called as a geographical arrangement of systems or a structure of a network or the way in which systems are interconnected with each other in a network. For example, we can say that if the spatial arrangement of a systems in a network is like a star fashion, we can call it as a star topology. Or if it is in a ring manner, we can call it as a ring topology. Or if it is like an interconnected manner, we can call it as a mesh topology. That means the spatial distribution of individual nodes in a network, that is what we mean by the term topology. Now, moving on to the next topic, that is different types of topologies. In computer networks, we have 7 different types of topologies, starting from the very simple one, point-to-point topology. Second one, the linear bus topology. Third one, ring topology. Fourth one, the star topology. Fifth, tree topology. Sixth one, mesh topology. And finally, the 7th one, that is the hybrid topology. On looking to these figures, you can easily infer that the name of the topology depends upon how the systems are arranged in the network. So, based on the spatial arrangement and the shape of the systems in the network, we are classifying these topologies under 7 categories: point-to-point, bus, ring, star, tree, mesh and hybrid. Now, moving on to the first one, that is the most simplest one, point-to-point topology. Point-to-point topology, as I said, it is the simplest of all the network topology. It has a direct link between one system to another, and this is faster and more reliable than other types of connections since we are having a direct connection. The main disadvantage of this particular topology is that it can only be used for small areas where computers are in close proximity. Okay, now moving on to the next one, that is bus topology. The bus topology usually consists of one main cable to which all nodes are directly connected. And here in this figure itself, you can see different nodes, node 1, node 2, node 3, node 5, node 6, etc. are connected to a backbone cable. This is the backbone cable and is the central part of bus topology. And one among the systems in bus topology will act as the server. The first advantage of bus topology is that it is easy to connect a computer or a peripheral device. The second advantage is that the cable requirements are relatively small, thus resulting in a very lower cost. The main disadvantage is that the center main cable, that is the backbone cable, breaks, the entire network will go down. This type of network is also very difficult to troubleshoot. For these reasons, bus topology cannot be used for large networks such as those covering an entire building. Next is the ring topology. In ring topology, the computers in the network are connected in a circular fashion and the data travels in just one direction, as you can see here in the figure. If there is a problem in the network, it is easy to pinpoint which connection is defective. It is also good for handling high volume traffic over long distances, since every computer can act as a booster of the signal. On the downside, adding computers to this type of network is very difficult. And one more main disadvantage is that if one system fails, the entire network goes down. Moving on to star topology. In star topology, each computer is connected to a central hub using a point-to-point connection. The central hub can be a computer server that manages the network. And here it is very easy to add new nodes to the network. And the network is very robust in the sense that if one connection between a computer and the hub fails, the other connections remain intact. But if the central node or the central hub fails, the entire network will go down. It also requires more cable than bus topology and is therefore very expensive. Now, tree topology. A tree topology is a type of structure in which all the computers are connected with each other in a hierarchical fashion. The topmost node in tree topology is known as a root node, and all other nodes are the descendants of the root node. The breakdown in one station does not affect the entire network. It has a point-to-point wiring for individual segments. A tree topology mainly relies on main bus cable, and failure in this main bus cable will damage the overall network. If any fault occurs in the node, then it becomes difficult to troubleshoot the problem. Next one, that is the mesh topology. There are multiple paths from one computer to another computer in a mesh topology. It does not contain a switch or a hub or any central computer which acts as a central point of communication. Below you can see two figures which depicts two types of mesh topologies. In the first one, you can see all the computers are directly connected to each other. Such a type of mesh topology is what we call as a fully connected mesh topology. But in the second figure, you can see the computers are interconnected, but they are not fully interconnected. Such a mesh topology is what we call as a partial mesh topology. The main advantage of mesh topology is it is reliable, because if any link break down, it will not affect the communication between connected computers, and it gives a fast communication between the nodes. Mesh topology networks are very large and very difficult to maintain and manage. If the network is not monitored carefully, then the communication link failure goes undetected. So that is regarding the two types of mesh topologies, fully connected and partially connected mesh topology. Now coming on to the last one, that is hybrid topology. Hybrid, as the name indicates, it is a type of topology that uses two or more different networking topologies. The choice to use a hybrid topology over a standard topology depends on the need of a business, school or the user. The number of computers, their location and the desired network performance are all factors in the decision. And in this particular figure, you can see a hybrid topology where a star topology and a ring topology is combined together to form a hybrid topology. We can see one more example. Here we can see the combination of a bus topology as well as a star topology, which make it a hybrid. Application area of different topologies. As you can see here, different topologies and their areas of application are listed. Coming on to the first one, bus topology. Bus topology's implementation mainly comes in LAN application. Bus network topologies based on Ethernet cabling are relatively easy and economical to install, though runs are limited by the maximum available length of cable. but we can do expansion by joining two bus cables together, but this topology works best with a limited number of devices. Next is the star topology. Star topologies are most common in home networks where the central connection point may be a router, switch or network hub. Now coming on to the next one, ring topology. Ring network topologies are most often found on school campuses, though some commercial organizations also use them. Next is mesh topology. Mesh network topologies are typical for the use of internet and certain WANs. WANs stands for wide area networks. Coming on to tree topology. Tree network topologies, which is having a root node and a hierarchical structure, is oftenly used in WANs, that is wide area networks, and it is an ideal system for workstations also. Next is the hybrid network topology. Hybrid network topologies may be adopted to ease the burden of error detection and troubleshooting, or we can use it to allow a network to be scaled in size more easily. They can, however, lead to undue complexity and increased cost for sure. So that's all regarding the different types of topologies and the application area of topologies. In the next video lecture, we will cover the topics ISO OSI model, and the need for layering will be discussed, and the 7 layers of ISO OSI model will be introduced. After that, we will discuss TCP IP model and the layers of TCP IP model. Then we will do a comparison between ISO OSI model and TCP IP model. Thank you.